Welcome to part 2 of video series on linear regression. In this part, we will be creating dataset with our input and output values, which we will later use to train our linear regression on. In order to try our linear regression, we obviously need some data. We need our input data X and output data Y. And in order to achieve this, I suggest that we create some dataset artificially. Obviously, we could have downloaded some existing real-life data from internet. There are so many sources where you can get real data from, but it will be a little bit too complex at this point, because at this point we only study how linear regression works. We are not solving any practical task. We just need to see how it works. So it would be much easier to see it if we create some kind of ideal data set. Means that data set will be linear by design, because we will make it linear. And then later we will move to something more complex and something closer to real life. Our dataset will describe the price of some mysterious merchandise. And honestly, I don't know what this merchandise is. I just made it up for the purpose of illustration of a possible dataset. And we assume that price will depend on 7 input variables. It will depend on weight, and we also see that we have some range for each variable. So weight could be between 10 and 1,000 pounds, and coefficient for the weight will be 1.5, means that the component of our formula will be weight multiplied by 1.5. Plus, it will depend on volume in gallons, and the coefficient, as you can see, is 0.8. It will also depend on what color of the item. We assume that items of different color may have different price, and if it is black, we just add nothing to this. If it is green, we add $2 to the price, and if it is white, we actually subtract $3 from the price. We think it will also depend on age, and it's assuming that we are selling not only brand new items, but used items as well. And obviously this dependency is negative, means the bigger the age is, the less the price, and the coefficient is 15. It means that, for example, if item is 2 years old, we will take off $30 of the price. And we think it also has some voltage, and there is some dependency on voltage. It also depends on availability, and once again this dependency is negative, means the longer we need to wait for this, the less price it would be. And we think that availability will range between 1 and 25 days. And finally, it will depend on reviews. Reviews are reviews posted on internet by customers who previously purchased this item, and they could be ranging between 1 and 5 stars. And the dependency here is 10, so for every 5-star item, we will add $50 to the price. And the last row here, as you see, is intercept. This is actually our free component of our linear formula, which we add finally to every price, and this intercept in our case is 500. And also I would like to know that all these parameters, except of color probably, could be fractional, so they are not necessarily integer. For example, reviews could be something like 3.6, and age could be not necessarily even number of years, but it could be something like 2.5 years. So these are our input variables, and our output is our price. And finally, we have our calculation formula. And this formula is a linear expression which connects our input variables with price. And you see that each input variable is multiplied by a certain coefficient, and then they're all summarized, which is actually by definition a linear expression. You can argue that the last component, the component which refers to color, looks maybe not very linear. because it has some kind of logical condition, but it will fit into linear formula perfectly, as we will show later when we actually implement this formula. And finally, we are in our working environment, which we will be using for writing and testing Python code. And this environment is Jupyter Notebook, or to be more precise, is actually Jupyter Lab. Jupyter Lab is a new version, a new generation of Jupyter Notebook. However, classic Jupyter Notebook will work as well. You're probably already a little bit familiar with Python, as you decided to watch video series on linear regression, which is working on Python. And in this case, you know that Python works in a very big variety of environments. It works on so many different environments, I would not be even able to list all of them. But Notebook or Jupyter Lab is a very convenient environment for education purposes. You can install it on your own computer. It's currently open source software, or you can use big variety of cloud services available, which also provide Jupyter Notebook facilities. And some of them are completely free, some of them are working for small fee, but I would not be reviewing all of them. You will probably be able to find on Google if you just enter this as a search strings. You will see how many services are available. So until the rest of this video series, we will be using this Jupyter Lab. However, in production, you probably would not use environment like this. You probably would want to have your Python program compiled, maybe using Visual Studio. This is what I would personally use, or again, using a variety of other tools. There are so many tools which could compile Python programs. We start from importing modules, which we'll be using for this task. We will need module pandas. I will shortcut it as PD. Pandas will be useful because I want to generate our data set as a data frame. There are many ways how you can generate your data set. You can generate it also as NumPy array, but generating it as a data frame has the benefit of having column names, and also has the benefit of using some functions which pandas provide. We will see it later for analyzing of correlation between values. The next module we will need for this task is random, because I want to introduce some randomization into how we generate our input values. I don't want to have sequential values because it will be too artificial, so let's have them in some kind of random ranges. And also another module I want to include is joblib module. This module will be useful as we want to save our results in file and load it later. As you're probably already familiar with Python, I assume you understand that when you import modules, you first need to make sure that they're installed in your Python environment. So my modules are already been installed. If you need to install something, there are many ways of doing this. I am doing the most basic one, which is based on pip utility. For this, you will just go to your command line and run pip install and your module name. There are many other ways to install. For example, if you are using Visual Studio and keep your Python environment there, the Visual Studio has its own tool to install it. So at this time, I think we already installed everything and we have imported our modules. I now click on execute. It's been executed. So we are ready to go to our further steps. I will need to create a list with our possible choices for color. I will call it color. It will be standard Python list. And as you can see, with Jupyter Lab, it's very convenient to type something in because it helps you by closing whatever you open it. For example, if you open it brackets, it will put closing bracket automatically. If you put apostrophe, it will put another paired apostrophe automatically. So I'm using this benefit here, and I'm entering our three color which we may have, and which are black, green, and white. So black, and again, as you have seen, apostrophe was closed automatically. Then we have green, and the last color is white. So we now have this list, and finally we creating our pandas data frame. This is where we will be this is where we will record our data set into. I will call it dframe and create it like this: pd, which is prefix for model pandas, and the class is dataframe. Sorry, it should start from capital D, dataframe. And now in parentheses, I need to specify columns I'm going to have. We are going to keep 7 input columns here and 1 output column. So this is parameter columns, and it's specified as a list of column names, and columns we will be having are weight, our first input column, and the next column will be volume. And then we have color. What else we have? We have age, voltage, availability. I will prefer apostrophes rather than double quotes. Availability. And finally we have reviews. So far these are our all input columns, and our last column will be our output column, which is price. It was possible also to create separate data frame for price, but I find it convenient to keep everything together, to keep all input and output data in just one data frame. The next step would be to put data in our newly created data frame, and I am going to put 50,000 rows into this data frame. So our linear regression will have to process 50,000 of input cases. And it's almost all ready to go. It will actually work in the form like it's written now, except that it will not be optimal in terms of performance. And this is because we just created empty data frame, and every time we will be inserting a row in this data frame, it will be internally rebuilt. So it will be rebuilding entire data frame, and it will be pretty slow. It's way easier, means way faster to create data frame of some predefined size. So to create data frame which already has 50,000 rows. And in order to do this, we need to put another parameter into call of constructor of the class of data frame, and this parameter is index. Index will refer to index of our rows. Actually, columns, our previous parameter, is also kind of index, but this is index for columns, and this index is character. We address our columns by their names, and our index for rows will be integer. We will be simply addressing them by numbers 1, 2, 3, 4, 5. And the best way to do this is to create index like another pandas class, and this class is range index. So I put pd prefix, meaning that I refer to something from pandas library, and I type range index, and in parentheses I will specify first and last value of the index. It will be 0 through 50,000. So this way it will work way faster. There is only one note I need to make about this maximum value 50,000. It may look like this is a range of our values. They start from 0 and end at 50,000. It's almost true, but not exactly true, because the way how Python works, very often index, the maximum value index is one less than the maximum value specified. So this range index will create values from 0 to 49,999. So it will be 50,000 minus 1. And the total number of values will be 50,000. This is actually what we wanted, but the maximum value is not exactly 50,000, it's one less than that. So this time the data frame creation statement is ready, and I'm going to execute it. It works fine, and we're ready to start filling it. Next, I will define function which would calculate our price based on our 7 input values. I will call this function price, and this function will take 7 input parameters which are our input values. And this would be weight, volume, color, age, voltage, availability, and reviews. And the way how I will write this function, I will start from very end, meaning that I will skip for now how we process color because it's a little bit different, and I will type in directly the formula which calculates our price based on other input parameters. I need to correct some misspelling here, and our function will return weight multiplied by its coefficient, and the coefficient for weight is 1.5, plus volume multiplied by its coefficient, which is 0.8. Now age is multiplied by a coefficient minus 15, so instead of plus I put minus here, and I will say age multiplied by 15. Sorry, 15. Plus voltage multiplied by 2.5 minus availability, again minus because availability has negative coefficient, and coefficient for availability was 2, and plus reviews multiplied by its coefficient, which is 10, and finally plus our intercept 500. So we covered everything in our function, I mean all input values except color. And color requires us to have some logical expression. This is why I actually put it to be entered later. And now I'm adding color as color value. So there will be some numeric value which will be added to our formula, and color value will depend on what color is being passed to the function. So we will assume that by default color value is 0, and this would be case if we pass it black. If our color is black, in this case we are not adding or taking off anything. But if color is green or white, we are making adjustment. So if color is equal to green, we will make our color value, and this is component which is added to our final formula, we will make it equal to 20. I will copy it and paste in order to enter similar statement for white. If color is white, I omitted equal sign, equal to 20. If color is white, then our color value will be negative and will be equal to minus 30. So I now calculated color value, and at the end I can simply add it to our final formula plus color value. So it looks like this function is done, and I am executing this cell to check that syntax is right, and it looks like it's working good. And now it's time to start filling our data set. We will need to write cycle which will have 50,000 executions. So we will do it like this. for I in range 50,000. And please note there is the same trick here as we already talked before. The I will range from 0 to 49,999. It will never reach 50,000, but the total amount of execution will be 50,000 because it starts from 0. And within this cycle, let's assign value for our every input variable. Our first input variable is weight. Like this, weight. And the value we will be assigning will be some random value in the range where this weight should be. As you remember, we defined range for every input variable we have. In order to make random variable, we will be use random library. As you can see, we imported it already. It's called random, and we have prefix R and D for this, and we will use random function uniform, which will be return as some random value within uniform distribution. Uniform distribution means it's even. It means that every value in this range is equal likely. And the range for our weight is between 10 and 10,000 pounds. I'm sorry, the maximum value is 1,000, not 10,000. And I will use it as a template. I will copy and paste it and create our other variables using the same pattern. So our next variable is volume, and volume changes between 20 and 50. So the range here will be here 20 through 50. The next is age between 0 and 15. I will put age and 0 and 15. We have voltage between 12 and 24. We have availability between 1 and 25. And we have reviews between 1 and 5. And few words about using this randomization here, I mean this random uniform function. The alternative way would be to just use sequential values. For example, we could make our weight grow sequentially from 10 to 1,000, and the same could be done for volume. We could pick up certain step and make it grow from 20 to 50. And for linear regression, for this particular model, it could be even acceptable because when you draw straight line, it's not really very important in which sequence you have values. It's probably going to make the same line anyway. But in general, in machine learning, it's better to randomize your input values. I mean, randomize the sequence in which they are supplied. Otherwise, your model could be confused with some calculation. For example, if it starts at the beginning to work only with small value, and at the very end it only working with very large value, it can actually make this calculation complex, and it may lead to wrong results. So in general, it is recommended that your input values are coming in some kind of random order rather than when they line it up from small values to big values. And also, this randomization somehow reflects real life. In real life, you would not have perfectly lined up data. You would have data coming in random order. So doing this randomization makes our example to look a little bit more realistic. So we worked out all our input values for certain row in our data frame for all our numeric input values. The only input value which we didn't cover yet is color. And if you remember, color is somehow different. It's not numeric. It's supplied as 3 possible choices. So we will put it separately. So now it's the time to calculate our price using previously defined function price. So price will equal to price, and as a parameter we will be passing our just random value of weight, which we just worked out, volume. And now for color we will be using list, which will be defined before. And that was actually the purpose why we defined it, because we will need to pick up next value based on our control variable I. Our control variable I, as you remember, ranges from 0 to 49999. And here we will put expression like this. I %3% in Python means remainder. So by calculating this remainder, we're making I run between 0 and 2 all the time. So it will be running like 0, 1, 2, and again 0, 1, 2, and again 0, 1, 2, and so on until we reach the end of our cycle. And this is exactly what we need, because 0 means our first color, which was black, then green and white. So our list helps us to pick up colors when we have I as input value. And the rest of our parameters are pretty straightforward. It's age, voltage, availability, and reviews. So we now have cycle which calculates everything. It calculates all our input variables and our output. So now all values we needed have been calculated, and it is a time to record them into our data frame. In order to do this, we will use expression like this, dframe, then ilog, and in brackets we will put I. This ilog property allows us to access either rows or columns by their number. So ilog I means that we are recording into row number I. And please note, we are not creating this row, but we are also assigning value to this row, because as you may remember, we already created all 50,000 rows before. If we needed to add new row which didn't exist, we will need to use different method. So what we would assign is actually a list, and list will be of all 8 values we are recording into our rows. The first 7 values are the same as we had parameters for price function, so I will simply copy and paste them. I'm copying it here from the list of parameters and pasting them into our list, which we will be recording into data frame, and the only thing I need to edit is price. This is our output value. So at this time we have everything ready, and it's time to just execute this cell. This star before the cell means that the process is running. It just ended. And just few words about this execution. I deliberately made it not very performant. The best way of doing such expression will be to vectorize them, to use some kind of vector approach. And vector approach means that instead of creating individual values for weight, volume, age, and all other variables, we could have created 6 vectors of variables. So weight will be vector. It will be a vector which has 50,000 values, and volume will also have 50,000 values. And then we could have applied our Python function to vector. If vector is created as numpy array, it will apply vectorization and our calculation will be perfectly fast. It was not very slow this time, but if we do it with vectors, it will be almost instant. So Normally we will utilize vectorization, but this time, because we have some kind of complication, and complication is caused by color, and color is not perfectly fitting into our numerical calculation, it was logical expression, I decided to not use vectorization. It still was possible to use it if to do some trick with colors. For example, you could have created 3 separate vectors for each color, but I simply thought that this time it's more important to explain the logic rather than to do it in very performant way. But for future, it would be very important to know that whenever you can use vectorization, then use it. Especially it is true when you're deploying your system in production. Right now, we simply writing something to learn this code, so it's maybe not a big deal when it's not very performant, but when code is deployed into production, it's very important to make it as performant as possible. And as our data frame has just been created, we are probably very curious to see how it looks like. In order to see this, we simply can type dframe, our data frame name, and execute it. And I will scroll now. It shows actually first 5 rows and last 5 rows of our data frame. It's obviously not showing of 50,000 because we will not have space on our screen and to see this. And now you can see that the values which were generated are the kind of values we expected. So the first column is weight, and you see the values for weight are in the range as we wanted, and the same applies to volume. And color is text. It's either black, green, or white. And age and voltage and everything else is how it's supposed to be. And price is the price as we just calculated. And once again, you see that in total we have 50,000 rows, but the last index is 49,9999, and I already explained before why this happens this way. And now we are almost done with generating of our data frame of input and output values. And I am saying almost because there is still one problem which we have to address, and this is pretty subtle problem. It's actually very easy to overlook it. And this problem will be shown if we check data type of stored in our data frame. In order to do this, I am typing dframe dtypes. Dtypes is property of data frame, which is showing what data types are stored in the cell of this data frame in each column. And I am executing this, and I am see that they are all stored as object. And this is actually pretty much disappointing, because object is very generic type, and we wanted particular type. We wanted to store them as float values, because we will need to do some calculation of them. And if they are stored as object, many methods which are very useful on data frames will simply not work. We will see later what methods I mean. At this point, simply believe me that storing them as object is not good way of storing them. Fortunately, it's not very difficult to fix it. What we have to do, we simply have to call special function on data frame which is convert dtypes, and this function will do the following. It will review all actual data stored in our data frame, and it will try to pick up the best type which describes them. So what we need to do, we need to put dframe convert dtypes, and as this function does not convert data type internally, but simply create a new data frame with new data type, we need to reassign it to our existing data frame. So our data frame will be now whatever data frame will be produced after we convert the data types. We execute this, it works immediately, this is good. And now it's good time to check data types again. I will not type it again because I already have it here, so I will return to this cell and I will execute it now again. And finally, we see exactly what we wanted to see. At this time, you see that all data types are float 64. This is how our float numbers are stored, except the color, which is string. And this is perfectly correct. This is exactly what we wanted. So at this point, we are really done with data frame. It has both correct values and correct types. And just few words why this correction of types was necessary, why this occurred in first place. Actually, that was direct result of us making some performance improvement earlier. I just scroll it up back and I wanted again to concentrate on this statement which was creating our data frame. As you see, we supplied index with certain range index, so we created data frame of certain size. But at that point, data type was not known to pandas. So when we requested certain size of data frame, which was of 50,000 rows, it had no other choice other than to create them all as object, because object is most generic type. So that makes sense. However, later when we assigned some values, we were assigning them right here when we executed dframe I statement assignment. It decided that object is already a convenient type because object could fit everything. So when we assign more specific value like weight volume, which is float, it decided it would perfectly fit into object type. So it never changed this object type to a proper type. In my opinion, it's not the best way of thinking about this, but this is at least how pandas works, and we have no control on this. So when it already has object, it doesn't automatically change it to a more proper type because it thinks that that object would be sufficient. And this is why we had to fix it manually by executing this dframe convert the types. Very important note, because very often people will create this with object type and some function and methods later simply wouldn't be working at all. The last thing we will do in this video part, we would store our data frame for persistent storage, meaning we will save it in a file in our hard drive. Obviously, we need to preserve our data frame for future. We will be doing many experiments with this. We will be returning to it many times. At this time, it only exists in memory, and obviously we want to save it. For example, we want to use it tomorrow. So in order to do this, we will use library called joblib. You probably remember we imported this library before. I will scroll up and show where we did it. So we put this import joblib statement. So we already have it imported. So what we have to do, we need to type joblib, and the method from this library is called a dump. And the first parameter for this method will be our data frame name, dframe. And then we simply need to pass to our file where we want to store it. I will put it as a data and the file name merch dat, where merch stands for merchandise and dat simply extension which I pick it up for data. Data is actually the name of subfolder of whatever folder your notebook is stored in. We're currently using this notebook part 2, and it's stored in some folder, and data is expected to be subfolder of this folder. So if we did everything correctly, it should now work. I am executing this, and yes, it worked fine. It took almost no time, and now it reports that it stored our data frame within our specified folder and path. This is end of part 2 of video series on linear regression. In this part, we created input and output data set. We looked at some problems and challenges with creating of data set, some performance problem associated with this. And finally, dataset was created and stored on some kind of persistent storage. In next part of video, we will be using this dataset with our experiments on training linear regression and see what kind of problems we may encounter at that time. Thank you and see you later.